Hey guys, so we are starting Unit 2 today, and I'm going to try to do the notes a little bit differently. So, as you know, I'm still trying to figure all this out, and last unit I had a little bit more time to figure out how to do the notes or change the notes and make them maybe reduce the notes for you because you guys weren't back in school yet. But now that everybody's back in school and I've got 100 kids in class and I've got 50 kids out of class and everybody's emailing me, and it's just been so crazy. And I know it's been crazy for you too, and I want to know that I'm sensitive to that. I know it's been kind of stressful, but guys, you've been wonderful. You guys that are in class, you've been so wonderful. And I have a lot of kids that are remote that are working hard. I have some kids in remote, they're not doing anything, and I don't know how to help them. But I want to say a shout out and appreciation to everybody that is working really hard in class and at home. I know it's not easy, especially for those of you who are home right now. But I can appreciate what you're doing. I understand, and I wish I could stay home too. Okay, so with that said, we're going to go ahead. As you can see, the notes are already completed. They're in front of me. And so I'm going to scroll down these notes, and hopefully you have a hard copy of these notes. If you don't, I will be providing them to you guys. So look out for that email if you haven't seen it already. So I don't know if you remember when you would do y equals mx plus b, but we're kind of going to revisit that and name some things, names that you've probably heard before, which is independent and dependent. I want you to think about like buying a chocolate bar. In fact, we can just zero in on this example right here. There's a lot of notations, but you can see y equals 3x minus 4. Just for a moment, ignore the minus 4 and just think about y equals 3x. So 3 in this example would be the price of my chocolate bar, and x would be the number of chocolate bars that you buy, and y would be your total cost. And you know that the more chocolate that you buy, the more expensive it is. So y, the total cost, depends on x, the number of chocolate bars that you buy. So we're going to be talking about that, defining those sorts of things and creating equations based on those things. It's going to be super important that you understand the concept of independent and dependent, X and Y, because that's going to play a part throughout the pretty much the entire year in algebra as we work with X and Y in various different equations. So coming back up to the top, independent is the one that it doesn't matter. Like, it doesn't matter how many chocolate bars you buy. You might buy one chocolate bar, you might buy two, you might buy three. That's independent. But the total cost, that's dependent. The total cost in the example I gave depends on the number of chocolate bars that you buy. So Y depends on X. Independent, dependent. Dependent depends on the independent. Then we have this other thing called a constant. A constant is something that doesn't change. For example, an example that I give a lot of times is I'll say, okay, so you're buying $3 chocolate bars, but I own the Willy Wonka chocolate factory. And so just to come into my Willy Wonka chocolate factory, you have to pay $5. Now, it doesn't matter if you buy one chocolate bar in the factory or 10, you still owe me $5. It is the constant. And so if you can remember the equation y equals mx plus b, that b that's hanging out on the end, that's adding or subtracting, kind of like this negative 4 right here, it's not going to change. It's constant. It's always there no matter what. So that's what we're going to be identifying. We're going to read a few equations. We're going to identify the different things. I don't know if I'm going to go through all of these, but we will definitely hit a few of them. I'm going to skip this first one because I want to do one that's more familiar to you first. So number 2 says, Sally bought a soft drink for $3 and candy bars for $1.50. She spent a total of $33. How many candy bars did she buy? So it says she bought one drink. That's our constant. We don't know how many candy bars she drank, but that drank. how many candy bars she bought, but that's the independent because the total cost will rely on how many candy bars she bought. So this I for independent is the number of candy bars. The D, which is the dependent variable, is the total spent. We'll call it T. And they already told us that it's going to be $33. So we don't need to put a capital T into the equation. We can just say $33. The cost of the soft drink is $3. And that's the constant. That's what's not going to change. So if I create an equation, there is the T for dependent, which eventually we say is $33. There is the cost of the candy bar, and this would be normally be an X. We're looking at it as a B, but that's going to be the number of candy bars that she buys. We don't know what it's going to be. And there is the soft drink. That's the constant. It doesn't change. And so I've created an equation, and then here I am substituting. Now you probably see ROC. That's called the rate of change. So as you buy one chocolate bar, or you buy one chocolate bar, that's $1.50. Two chocolate bars, it's $3. Three chocolate bars, it's $4.50. So the rate of change is $1.50, and that doesn't change either. It's like plus $1.50, plus $1.50, plus $1.50. Okay, let's go back to this one right here. This one we have a gumball machine, and I don't know if you remember the days back in the days when there was a Blockbuster Video. They had this giant gumball machine in there. So it's saying that this giant gumball machine weighs 40 pounds, and we want to know the total weight. Well, the total weight depends on the number of gumballs that are inside of this gumball machine. So you can see that the total weight of the machine is 40 pounds, and each gumball only weighs 0.06. That's my rate of change. One gumball, I'm going to add 0.06. Two gumballs, I'm going to add 0.06 times 2. Three gumballs, I'm going to add 0.06 times 3. So the independent, the thing that could change is the number of gumballs. The total weight depends on the total number of gumballs. And then the constant, the thing that doesn't change, is the weight of the machine. So even if you have no gumballs at all, you still have the 40 pounds. So you can look at this equation right here. If you had, there's a good example, if you had 0 for the number of gumballs you had, you would still, the weight would be 40 pounds. And then what we're doing, we're adding 0.6, adding 0.6, adding 0.6. I'm going to skip over number 3 because it's a little bit more than I feel like we need to be covering. Okay, this one not right here, number 4. This one does not have a constant. So what it says here is that you're attending a conference in downtown Dallas for the next 4 days. You have to pay $4 per day in order to ride the DART. Ride the DART downtown. That's the bus system or the subway system. Determine your total cost. So, depending on the number of days, that's going to determine the number of $4 that you're paying, because you're going to pay $4 per day. That total cost also, it depends on the number of days. There is no constant. I don't have a beginning fee or anything. It's just every day I need to pay $4 to use the public transit. So my equation is just C, the total cost, equals $4 per day, and then D is the number of days. Now, we went ahead and substituted in 4 because it says I'm going to be there for 4 days. So I already know how many days it's going to be. D is 4. Okay, let's look at number 5. Dave measures how many inches his tomato plant grows every week. The plant started at a height of 4 centimeters. So it started at 4. It might die. If it's anything like my basil that's growing right now, that since school has started, I'm basically killing, it's not going to grow anymore. It's going to stop. So that's my constant 4. Now, but David is doing a much better job with his tomato plants. So they're growing 2 inches every week. So 2 inches, 2 inches, 2 inches. Now let me ask you a question, thought-provoking question, which I will close with. Will that tomato plant continue to grow for infinity? No. So that's like a constraint that's on the two. And eventually we'll talk about constraints. But right now, just understand we're just going to go ahead and add 2 inches, 2 inches, or yes, 2 centimeters, 2 centimeters. That's the rate of change. But of course, eventually it's not like my basil, it's going to die. So, David, good luck with that on your tomato plants. So, I'm going to close with that. We have an assignment. Good luck with it. Please ask me questions if you don't understand what I just said, because I know sometimes that can be very confusing. But it is awesome talking with you again. See you later. Bye.